Good morning, everyone. Let's start with this new chapter on Introduction to Wind Energy. Okay, so here, we'll just give a brief introduction to wind energy and look at different types and look at its history in brief in terms of how it can be used. Now, wind or airflow, as we know, it occurs naturally and in fact is an indirect solar energy source. So, wind energy is an indirect form of solar energy, right? And it happens essentially because of the temperature variations which move the wind around or which cause the airflow. And the purpose of this chapter is to sort of figure out how we can make use of this energy available in the wind, right? So in terms of its characteristics, of course, it's an environmentally clean source of energy. It's pollution free during use. In terms of extracting energy from the wind, wind or airflow is intermittent, as we are very well aware, and it is a dilute source of energy, as is any other renewable source of energy. Right now, in terms of applications, wind or the energy available in the wind has been harnessed for various purposes throughout history. Initially, it was used for water pumping for irrigation, land draining, grain milling. This was what they wanted to do, what people wanted to do, maybe 100 years ago. And then recently, because of our move to electricity and electricity-based devices, now we are sort of making use of wind turbines to sort of generate electricity. So the power of the wind has been harnessed historically for various reasons, and it continues to be harnessed. The applications are simply different. So this is a very old windmill, essentially, that was used for grinding or grain milling, and you'll find these kind of windmills in Netherlands and in Europe, various parts of Europe, even up to now, right? It's also been used for various other purposes, but for us, the purpose of this chapter is not to look at windmills or applications like grain milling, but the idea is to look at how we can use the power of the wind to generate electricity through wind turbines, like the one shown in this picture. Okay. Now, in terms of extracting the energy from the wind, we also need to have some data available to make sure it makes sense, economic sense, to install a wind turbine at that location. So there is enough data available about the wind's availability pattern in terms of when do you have, at what times of the day, which seasons of the year, which months of the year do you have it, and at what speed do you have it, right? So this is a picture giving us a global mean wind speed, right, at a height of 80 meters. Okay, this is roughly where the hub is installed for most of the wind turbines. So, I mean, you have different sizes, but this is given as 80 meters. So, you can see wind speeds in terms of miles per hour as well as in terms of meter per second, and essentially the darker regions are the ones where you have higher speeds, and those are more preferable, right? So in terms of installing a wind turbine, you would ideally want to have an area with an average wind speed of 6 meter per second, or equivalent to 14 miles per hour at a minimum level for generating wind electricity from the wind turbines at an economical scale, right? So that's the minimum. So here, talking about things which are yellowish or darker, right? So yellow or darker colors are good. Green and blue are not good. So essentially, these green and blue areas are not good. Everything else works for us. And as you see on the global map, it's relatively well distributed among all countries, right? A lot of countries have good wind energy resources. In terms of Saudi Arabia, this is how the picture looks. Again, this is colored in terms of the mean wind speed. This is the mean wind speed map for Saudi Arabia. Although this is at a different height, it's at 100 meters, and the lowest is the bluish is 3 meter per second, and then the highest wind speeds are 9 meter per second. So high wind speeds are good. Not too high, but reasonably high wind speeds are good. And you can see it's again almost well distributed within the country. It's very high in the region, which is Neom, and also on various parts along the western coast of Saudi Arabia. It's also reasonably high on the eastern coast, which is where we are located. So it's also reasonably high in the central region. So there are different areas, and the north, you could say. So there are different areas with reasonably good levels of wind, which can be harnessed for electricity generation. Okay. Now, in terms of the role of wind energy in Saudi Arabia, well, as we have been discussing about this topic of electricity generation, the idea is to continue generating a majority of the electricity from natural gas, but still we want to have different options to avoid burning more of natural gas or to completely eliminate the burning of oil for electricity generation. And that's where all of these renewables and other energy sources come in. So we will have some amount of energy generation from waste to energy, as we discussed in the chapter on biofuels or biomass. PV is going to contribute quite a lot, but again, it's as this sort of shows this curve shows the electricity generation along the time of the day. PV is going to meet the energy. Usually, it's only available during sun time, right? So you have some variations, and then more or less it's available during sun time. Wind can take the loads during daylight hours, but also at night, depending on the location. And then you could have CSP taking some part of the load, allowing us to operate beyond the daylight hours, right? Not 24/7, but at least 15 hours per day, depending on the storage capacity. So the wind is a complementary solution to the solar PV, to solar CSP, and waste to energy, and will contribute in decarbonizing the electricity grid in Saudi Arabia. In terms of the goals, by 2032, we expect 9 gigawatts of electricity to come from wind energy, right? And among the bigger projects that have been started, the Damat Al Jandal project, it's a 400 megawatt wind farm. It broke a world record for achieving the lowest cost of electricity, right? Lowest LCOE for onshore wind power, and it's at 2 cents per kilowatt hour. So this is it's economic. It is making use of available energy, and yes, it'll contribute to decarbonizing the grid. So it's a very important part of Saudi Arabia's decarbonization efforts, and we'll just look at figuring it out how this all works together and how we can achieve that, and through understanding the basics of wind turbines and wind energy generation in general. Now, in terms of conversion or extracting energy from the wind or harnessing energy from the wind, well, any machine that converts the kinetic energy which is available into the wind into a usable form, into the shaft power, we could call it a wind machine, wind turbine, windmill, whatever. And they usually require, expertise in a variety of fields. And we'll be focusing mainly on the mechanical engineering aspects or the energy engineering aspects, where we're looking at, how much can we extract based on simple physics. Now, the energy which is available in terms of the kinetic energy of the air or the wind, you can extract it to get mechanical energy in terms of grinding or of grains or similar things, or pumping water, like what has been done typically with windmill, as shown here. Or you could also have a water pumping windmill, again for water pumping and the other applications. Or you could have indirect conversion of this kinetic energy of the wind into electrical energy, right? Which is kinetic to rotation of the rotor, or mechanical energy of the rotor, and then fitting a generator to convert that rotational energy into electricity. And that is the focus of this chapter. Now, this is how a typical wind turbine looks like, right? And it is composed of various components, which we will look at in a lot of detail. Put simply, it it has an electrical generator at the top, of course, to convert the rotational motion of the fan into or of the wind turbine blade, sorry, to electricity, and a gearbox as well. And we'll look at why all of those are needed. Now, in terms of the commercial wind turbines that we have as of now, they can generate anywhere from 100 kilowatt to 5 megawatt of electric power at peak design conditions, right? And we'll understand more of this as we go beyond. And the blade span or the rotor diameter, right? This is we're talking about this diameter, right? So let me draw this again. So we're talking about this diameter. So this diameter has been sort of increasing year by year, and we are reaching really big wind turbine blades now, right? So in terms of uh, the um, the blade span or the diameter of this 3.2 megawatt wind turbine, this is built by Boeing Engineering. Its diameter was 97.5 meters, close to 100 meters, pretty big, right? And the rotation speed of the rotors is usually under 40 RPM. But when we go to larger turbines, it's or larger rotor diameters, it's reduced further to 20 RPM because the tip speed, the wind speed at the tip of the turbine blade it gets very high as we go to bigger and bigger turbines. Okay, so the main reason why we are looking at wind energy now, just like the main reason why we are looking at solar PV now, is because of the huge reduction in price. It seen about a 10 time price reduction in the last 30-40 years, and it has become comparable to the price of conventional fossil fuel driven power plants like the Dumatal Jundal wind turbine at 2 cents per kilowatt hour LCOE shows. Now, there are wind turbines already installed in different places across the world. Altamont Pass in California is the world's largest wind farm with 15,000 wind turbines. You can see wind turbines all over, right? And this produces about 3 billion kilowatt hours of electricity per year. Pretty large capacity, right? And in terms of the various countries, well, the US, Germany, Denmark, and Spain, they account for more than 75% of current wind energy generation capacity. Denmark has a very large number of wind turbine farms, and it uses the wind turbines to meet 10% of its national electricity production goals, which is pretty large, right? Now, in terms of the wind, well, of course, the wind energy is free, just like the solar energy is free and renewable. But the things for extracting the energy are sometimes expensive and have some advantages which we need to talk about and discuss. Now, of course, we had this problem of intermittence, which is the same with solar PV as well. You have wind energy only when you have electricity only when the wind is blowing, of course, and so the power output is unsteady, it's intermittent. And the other problem with wind turbines is that they need to be, of course, located where the wind blows, right? And which is usually far off or it's in the middle of nowhere. So it's far off from usual power grids because you don't have a choice, right? You have to put up a wind turbine where it makes sense to put up a wind turbine. And this requires additional construction of high voltage power lines or grids to take care of it. So you can see this very huge wind farm is sort of in the middle of nowhere, right? And that's usually the case for most wind farms, not just because we get wind only far away from cities, which is partly true, but also because no one wants to live near a wind turbine. It's very noisy, right? So despite these challenges, of course, wind turbines are useful and they will play um, more and more role in meeting our electricity needs, right? Much more than 10%, as is the case for Denmark now. In terms of the current state of the art for wind turbines, well, this is a very nice picture which shows where it's headed, right? The turbine blades are getting bigger and bigger. For this 5 megawatt turbine, the rotor blade diameter is 120 meters, right? And this is a Boeing 747 to show you the scale of this of the wind turbine blades that we have reached, and it's much bigger than a Boeing 747 plane, right? So that's roughly the scale that we are looking at. Now, over the years, huge innovations and different designs have been proposed and tested, right? And we're going to categorize the wind turbines in terms of the orientation of their axis of rotation. So you can categorize them on the basis of horizontal axis wind turbines or vertical axis wind turbines, right? They can also be categorized in terms of the mechanism, right? What is the mechanism that is providing the torque to rotate the shaft? What is the mechanism for rotating the wind turbine blades? It can be either left or drag. Okay. Now, among the different designs that have been proposed and tested over number of years, the vertical axis wind turbine designs or the drag up designs have not really achieved the efficiency or the success that has been normally achieved with horizontal axis and left type wind turbines, which is all the wind turbines that you see anywhere, right? So almost all the wind turbines that were built recently, commercial scale that is, or all the ones that are being built are left type horizontal axis wind turbines. And so for the purpose of this chapter, we will focus entirely on these kind of wind turbines.